Hello everyone and welcome to your lesson of physics. So today I'm solving the past paper questions of the topic vectors of A-level physics. So the statement and the theoretical question, I'm going to fast forward those. For example, the very first one, we have B as the right answer because the scalar has magnitude but not direction. And we'll be spending more time on the diagrams and the questions that you guys find slightly problematic. So let's say here we have the second one. So you're provided with a vector. It is a velocity vector of magnitude 75. The direction is 30 degrees from north. What are the components of the velocity vector in the direction of north and in the direction of east? So kind of an easy one. In the direction of north would be this component, and in the direction of east would be this component. So the upper one is the one which is making the angle 30 degree directly. So this one would be vector 75 times cos 30 because it is with the angle directly, and the second one 75, it would be sine 30 because this component over here is not touching the angle directly. So it would be 75 sine 30. So if you sort out this one, and you see the vector that is closer to the north, that component is more because the angle is the vector 75 meter per second. That vector is closer to the north, so that's why that component has more magnitude than the other one. Alright, let's move on to the next one. So you're provided with two forces and the angle between the two forces is 150, and we might be using this thing as well. If I extend this line over here, then the angle would be the difference of 180 and 150, which is 30 degrees. So that angle would be 30 degrees, or the angle of that force with the horizontal would be 30 degrees. Okay, what we need to find is we need to find the resultant force, and we need to find the expression if we resolve that resultant force into perpendicular components. Now this question can be done by different ways. One of the method is you first find the resultant force, you find the angle of it, then you find the perpendicular components, you find the expression of the perpendicular components. And the other method is, especially with the answers are given in such a way that you have to compensate these two forces as well. The given force is 10 Newton and 5 Newton. So what we're going to do is we're going to resolve the forces in the direction of either 5 Newton or along the direction of 10 Newton. So if we consider this force as reference, let's say we consider 5 Newton as reference, and I'm going to find the horizontal force, the net horizontal force, and I'm going to find the net vertical force. So we're going to do this thing. So let us first find the net horizontal force. So for the horizontal forces, we'll be having two things. We'll be having two forces. One of the force would be on this side, which is a component of the force of 10 Newton. And how much would that be mathematically? It would be 10 cos 30. So the force on the right side would be 10 cos 30, and the force on the left side was 5 Newton, so you subtract 5 Newton from there. So this is what you get for the horizontal force. So the one of the perpendicular component of the resultant force would be this. The expression would be this. Let's break it down for the vertical. For the vertical force, you have only a single force that is going to have the vertical effect, which is the component of 10 Newton. How much would that be? It would be 10 sine 30. Because the second force, this force 5 Newton, it would be having no vertical component, or there would be no effect of this force in vertical direction. So do we have these two expressions for the answer? 10 cos 30 minus 5, yes, over here, but 10 sine 30, we don't have the relevant second uh, component in the pair. So what we can do is, we see that for if we break down in the direction of 5 Newton, that is not working. So we can try to break down the forces in the direction of the second force, the 10 Newton. So I'm going to extend a line over here in the same direction as of 10 Newton, and another line over here with the horizontal. And then we know this thing, that this angle was 30. So this angle would also be 30. How do we know? Vertically opposite angles. First, we're going to find the overall force in this direction. What is the resultant force in this direction? In the direction of the 10 Newton force. Well, you have a force of 10 Newton in, you can say, northeast, and you'll subtract a force in the opposite direction. There's another force that is exactly in the opposite direction, so we need to subtract from that force. How much is this force? Well, we can see from the diagram, it would be one of the component of the force of 5 Newton. How much? 5 cos theta. So since it is opposite to 10 Newton, so I'm going to subtract it from there. 5 cos 30. And then in this direction, we have found the net force. We have found the component of the resultant force in this direction. Then there would be another component. Since we have to find the vertical components, the other component, the second component, would be perpendicular to this one. Only then we can call it vertical component. So the second component would be in this direction, and you see it is perpendicular to this one, and it can be called as one of the component of the force of 5 Newton. How much is that? 5 sine 30, because it is not with the angle directly. The second one was with the angle directly, but this one is not with the angle directly. So what do we get for the second component of force? 5 sine 30. Now, do we have an option in which we have 10 minus 5 cos 30 and 5 sine 30? We have C as the right answer. So we saw, if we break it down, if we consider the first one, 5 Newton, as the reference, and we start breaking it down, we did that, but there was no option to satisfy those pairs. So we break it down in the other direction, in the direction of the other force, which was 10 Newton, and from there we get the consistent options. Alright, so let's take a look at the next one. An object is acted upon by two forces. Okay, we can see on the diagram. What is the resultant force acting on the object? So the resultant force acting on the object would be, you can complete it with the vector triangle, or you can break it down into components, whatever way you're comfortable. So if you try to solve it by the method of vector triangle, you can draw the second force, 6 Newton, at the end of the first one. Let's call the bigger force the first one, 10 Newton, we call the first force. Then we draw the second force at the end of the first one. So your force of 6 Newton is placed or drawn over here. Then you complete the triangle by connecting the start point of the diagram to the end point. So that was your start point at the center of the sphere to the end point over here. Now this is your resultant force, this one. So then we can label it. So this one was, the upper one was, this one is 10 Newton, this one is 6 Newton, and the resultant force would be how many newtons? So first of all, we can find the angle. This one angle would be, how do we know? Because the angle of 6 Newton force with the vertical is 40. So that angle is going to be 40. And the magnitude of the force can be found out by using the law of cosine that we generally do. So a square equals to 10 square plus 6 square minus 2ab cos 40. Then you hit it on the calculator. So the magnitude of the force is 6.6. This is what we have for sure. The magnitude has to be 6.6. So okay, so we have only a single option in which the magnitude is 6.6. So we don't even need to find the direction. If we were asked to find the direction, we would have been finding this angle. You see, this is the angle that they have given in all the options. Angle with the north or angle with the vertical. We could have found the angle. We could have used a law of sine. If you want to find it mathematically, you see this side is now 6.6. You need to find that angle. You can use the law of sine as well. Let's move on to the next one. What is the horizontal component of the force? So this one is very easy. The horizontal component is given in this direction. If it is with the angle directly, it would be 20 cos theta. So 20 cos 53. 20 cos 53 would be 12 point something. So A is the right answer for question number 5. So what we need to find is the resultant velocity of the aircraft is in the direction due north. Okay, the resultant velocity is north. What is the angle and angle and the magnitude of the resultant velocity? Over here, this is the wind. And what is the magnitude of this vector? 200 kilometer per hour. This is the first vector. The resultant vector is towards the north, like this. This is a resultant vector. And where is the second vector? The second vector is in direction north of east, like this. So where do you connect the second vector? You connect the second vector at the end of the first one. So this is your vector number 1, this is your vector number 2, and this is your resultant vector. What is the magnitude of vector number 2? 800. So you can draw either way. The second way is you connect the two vectors first, and then you draw the resultant vector. So first I'm going to draw, let's call this one the first one. Okay, there can be a lot of variations in that. You just need to know the concept. The variations can be plenty of them. You call this one the first vector and this one the second vector. Let's see if we get the same thing. So I'm going to draw the first vector. How much is that? It is 800. And then I'm going to draw the second vector, which is the vector towards west, from east towards the west. So this is the second vector. How much is that? 200. Then we connect the starting point to the end point, and this is the resultant vector. So you see, you're getting pretty much the same thing every time. It is just the triangle is rotated, but the sides are exactly the same. So it is a similar triangle. And what we need to find is the magnitude of the resultant velocity and the angle theta. Okay, what is the angle theta? The angle theta is the angle of the 800 kilometer per hour, that one vector with the north. So this angle you need to find. And if we take a look at the first diagram, in the first diagram we need to find this angle. Theta corresponds to this one, because angle is given as the angle between 800 vector, the vector of the magnitude 800, and north. So in the second diagram, the angle between the 800 vector, 800 kilometer per hour, that velocity, and north is this one. So it totally depends on your choice, the way you draw it. The concept is same. There are a lot of variations, and you should be getting the same answer either way. So I'm going to consider this one. Looks very easy. Triangle. I'm going to find the side first. What we can do is we can find the resultant velocity, and the resultant velocity would be because we know this is a right angle triangle. How do we know? The wind was given towards the west and the resultant velocity is towards the north. So we are given, explicitly it is given. We're not just assuming that this is a right angle triangle. No, you cannot assume. You have to figure it out. If it is mentioned directly or indirectly, then it would be a right angle triangle. Otherwise, you cannot assume it to be a right angle triangle. So we can apply the Pythagoras theorem and we can find the resultant vector. So let's call it x. X equals to 800 square minus 200 square and then the square root of it. 774. So how many options do we have with this one? 74 into SF would be 770. So not B, not D. It has to be A or C. You can apply whatever identity you want. You can even use sine theta, cos theta, tan theta, because you have all three sides of the triangle. So I'm going to use theta equals to sine inverse of perpendicular, which is 200, because with respect to this angle the perpendicular is 200 divided by 800, so 2 over 8. Sine inverse of 2 over 8 or 1 over 4, it is 14. So we get A as the right answer. So even if you consider the second triangle for reference, you'll be getting the same answers. Okay, let's take a look at the next one. The vertical component of the velocity is Vy. What is the magnitude of the horizontal component of the velocity? So you're given with the vertical component of the velocity, you're given with the velocity itself, and you need to find the x component. It's a very easy one. What you can do is, you know this thing, that if you complete the triangle, you can draw the second one over here. This would be your Vy. This is your Vx. And we use Pythagoras theorem, and we can write V square equals to Vx square plus Vy square. And if you need to find the horizontal component, it would be Vx square equals to V square minus Vy square, and you need to get rid of the square from Vx, so Vx would be equals to this thing and then the square root of it, which is D. So for question number 7, you get D as the right answer. Alright, then we have the next one. P and R are coplanar vectors. They're lying on the same plane. X equals to P minus R. Which diagram best represents the vector X? So X equals to P minus R. You guys are generally familiar with the addition of the vectors, so you can rearrange it so that you get the vectors to be added. X equals to P plus R. We get this expression. So P has to be the resultant vector. X and R have to be the two vectors that should be joined by head to tail rule. And P has to be the answer. So if we consider, let's say we consider the first one. So P has to be the resultant vector, and X and R have to be the two vectors to be added. Let's say this is a vector X and the vector R in this direction, but it has to be connected at the end of the vector X. Yes, it is connected at the end of the vector X. And what do we do in the last step? We connect the start point towards the end point. We get the resultant vector. Do we get the resultant vector P in this direction? Yes, we do get. So A is the right answer for this one, the very first one. Let's check out the other options to clear the concept for this one. Let's say why not B? Why do we not get B as the right answer? So the equation says you have to add vector X and R. So where's the vector X? Okay, over here. But then where's the vector R? The vector R had then to be added at the end of the first one. So the vector R had to be in this direction. You have to place it at the end of the first one. Okay, just like you keep attaching the pencils. You have the first one over here, Then you connect the second pencil at the end of the first one, like this. Then you connect the third one and you continue in the same way. So B can't be the right answer. And likewise, you'll see the problem with the option C and D as well. Alright, so let's take a look at the next one. We have the vector F, the force vector, and P is just a component of that vector. And in this case, it is a horizontal component of the vector F. So what happens, what is the variation of with theta to the magnitude of P? So what they're saying is, what happens if you increase this angle of the vector F, then what happens to the component P? So let's say first then you change the angle, you increase it all the way here, then you increase it further all the way till here. Then what happens to the component P? And the obvious answer is, as you increase the angle, then the magnitude of P would decrease, because your vector is now not close to the horizontal axis or to the horizontal. So if the vector is over here, its effect would be closer to the vertical line. It would be having a higher vertical component compared to a horizontal component. The lesser the angle, let's say the vector were over here, in that case the magnitude of P would be more. But if you increase the angle, the vector gets away from that axis, so the magnitude of P would decrease. So we need to choose the option in which the magnitude of P decreases, and as the angle goes to 90, let's say eventually the angle is increased to 90, so that means your vector is purely vertical. For a vertical vector, it has no horizontal component, because even if you try to find this component of the vector which is perpendicular, you'll be writing F cos 90. Cos 90 is 0, so mathematically the answer would again be 0. So the angle would, increasing the angle, the magnitude of P would decrease, and if it approaches 90, it would be reduced to 0. And for this one, you see the very first option, A, is the right answer. Option B says increasing the angle, the magnitude is increasing, which is not the case. C is saying the same thing. So it is being reduced to 90. It is being reduced to 0 at probability. Okay, then we have the next one. The diagram shows two vectors x and y drawn to scale. If x equals to y minus d, which diagram best represents a vector z? Alright, so once again, what you can do is you can rearrange it for the addition of vectors. So we can write it as y equals to x plus z. So what is y? In this equation, y would become your resultant vector, because it is the sum of two vectors. So this is your resultant vector, x is your first vector, z is your second vector. And the resultant vector, which is y, has to be towards the right side. So the resultant vector has to be towards the right side. And keep it in mind, how do we plot the direction? How do we direct the resultant vector? It is from the starting point towards the end point. So this is your starting point. This is your vector number 1. Now you need to connect the vector z, which is your vector 2, in such a way that the resultant vector has to be towards the right side. So let's start off with the option, let's say D. Let's start off with the option D. So D says the vector D is downwards. So if I connect the vector, the second vector downwards, which is the vector z, and then I complete the triangle, the rule says, how do you draw the resultant vector from start point towards the end point? And this has to be the resultant vector. Now, is the resultant vector in the direction of y? No. So D can't be the right answer. Let's take a look at the option C. This option C says the vector z is upwards. Okay, so let's draw the second vector upward, because we have to connect the second vector at the end of the first one. Now we join the start point to the end point. Do we get the vector, the resultant vector in the direction of y? No. So C can't be the right answer. Likewise, B can't be the right answer. You can check it out by yourself. I'm going to draw the vector A. For the option A, the vector Z is on the bottom right corner. So I'm going to draw the vector Z over there in this direction, because we have to place the second vector at the end of the first one. So this is going to be my vector Z. In this direction. And what is the final step? You connect the start point to the end point, and you get the resultant vector towards the right side, which is consistent with the direction of y. So A is the right answer for this one.